Hi everybody and welcome back to the channel. In this lesson, we'll explore how to determine the relationship between two circles by analyzing their equations. By finding their radical axes, we can identify intersection points and prove that it is always perpendicular to the line connecting their centers. Let's get started. An important problem in geometry is determining the intersection points between two circles. To solve this problem, we need to solve the system of equations representing the two circles. First of all, let's find the centers of the two circles. Let's start from the first equation. We need to group the terms together. Then we complete the square. We do this because then we want to write these terms here as x plus alpha divided by 2 squared We know that the standard equation of a circle is x minus x0 squared plus y minus y0 squared equals r squared, where r is the radius and the center of the circle C is identified by x0, y0. This tells us that in our case, the center of the circle is minus alpha divided by 2 minus beta divided by 2. We can repeat the same steps for the second equation. And we'll find that the center is identified by minus alpha 1 divided by 2 minus beta 1 divided by 2. Let's free some space. Now, if the circles represented by these two equations are not concentric, which means that alpha is different from alpha 1, or beta different from beta 1, subtracting one equation from the other gives the equivalent system. So we can rewrite the first equation as it is, and then subtract one equation from the other. We will get alpha minus alpha 1x plus beta minus beta 1 y plus gamma minus gamma 1 equals 0. This means that the possible intersection points of the two circles must satisfy the radical axis equation. The points of intersection between the two circles must lie on this line. If the circles intersect in two distinct points, the radical axis is the secant line joining them. If the circles are tangent to each other, the radical axis coincides with the common tangent at the point of tangency. If the circles do not intersect, the radical axis still exists, but does not contain any common points between the two circles. Let's sketch a simple diagram. A fundamental geometric property of the radical axis is that it is always perpendicular to the line joining the centers of the two circles. To see why, we note that the centers of the circles are given by minus alpha divided by 2 minus beta divided by 2, and for C1, let's call this C1, minus alpha 1 divided by 2 minus beta 1 divided by 2. Now, the slope of the radical axis, we can see it from here. Basically, we can rewrite this equation as From here we can see that the slope of the radical axis is minus alpha 1 divided by beta minus beta 1. We call it m and we write it here. Let's free some space. The slope of the line connecting the centers, we call it MC, is beta minus beta 1 divided by alpha minus alpha 1. And this is simply the slope of the line passing through 2 points, in this case C and C1. We call this MR since it's relative to the radical axis. We can observe that these two slopes are the negative reciprocals of each other, and therefore the radical axis and the line joining the centers are perpendicular. Let's now apply these ideas with an example. We want to determine the points of intersection of the circles given by the equations x squared plus y squared plus x minus 7 equals 0 and x squared plus y squared minus 2x plus 3y minus 4 equals 0. First of all, we set up the system of equations. As we learned, we now subtract one equation from the other to obtain the equation of the radical axis and then solve for the points of intersection. We can see that this is a quadratic equation. In order to solve it, we need to apply the quadratic equation formula. If you remember, it is minus b plus minus b squared minus 4ac divided by 2a, where the reference equation is ax squared plus bx plus c equals 0. In our case, it becomes okay, so the final solution of the system will be for y equals 1, x will be 2, and the second solution is for y equals minus 5 over 2, x equals minus 3 over 2. So finally we can say that the two circles are secant in A, 2, 1, B, minus 3 over 2, minus 5 over 2, and the radical axis has equation x minus y minus 1 equals 0. Thank you for watching this video. I hope it was helpful. If you'd like to learn more about this topic, please let me know in the comments. Keep practicing and see you next time.